Well, good afternoon or morning, students, depending on when you are watching this. Today we're going to talk about how you graph your motion. One of the very first things that you need to look at are the axis and how they are labeled. So if you look at the graph in front of you, you will notice that on our x-axis we have time, and on our y-axis we have distance, which is labeled as meters. Okay, so the very first thing we need to talk about is, well, what if you see a straight line up? What does that mean? If you see a straight line up, that means that that person or object is moving at a constant speed because it's a straight line, and they're moving in a very forward direction. Then the second line that we come to is a straight horizontal line in the graph, which means that their position or their distance is the same over time. So that means that there's no speed or that the object has stopped moving. That third line that we see is still a straight line, which means it's still a constant speed, but notice how it has a negative slope, or it's going back to the x-axis, which means that the direction would be negative, or they're going back to the start. So one way that you can interpret this graph is that if the x-axis is your home, then you could interpret this by saying you walked across the street to get a cup of Starbucks, and you stayed in Starbucks for a certain period of time, and then you walked back home. So that would be kind of one way to interpret this graph if you wanted to. So now let's talk about the units. We saw earlier where distance is usually measured in meters. That's the base unit. Time is measured in seconds, and so speed is measured in meters per second, and what that looks like is a capital M, a fraction bar, and then an S. So it is M over S, meters per second. Now let's look at our equation for speed. We know that speed equals distance divided by time. So a little slash mark right there is really a fraction bar. So this is really a fraction. So you would take your distance traveled divided by the time it took you to travel that distance, and that would give you the speed. Now in math, we use the same equation, but we call it something a little bit different. So in math class, you might have heard this be referred to as distance equals rate times time. So rate and speed are kind of synonyms, so they're really the same thing. So if you want to rearrange the equation to figure out how far something will travel, you'll take the speed times how far or how long they are traveling. So this is also known as distance equals rate times time, which may or may not come up on the I step, hint, hint, wink, wink, nudge, nudge. Now, what exactly does the slope represent? Well, let's talk about slope a little bit. We learned the definition in our textbook that the slope is the rise over the run. So that means how far did you go up, and then over, how far did you travel over, right? So because in our distance over time, we know is speed, and on our position or distance time graph, we know that distance is the y-axis and time is the x-axis. And so we know that distance over time equals speed. We know that slope is the rise over the run. So we know that the slope of a distance time graph gives you the speed. And I'm talking really fast and really loud because that's a really big deal. So let's go back to our graph here. Okay, so there's your constant speed forward, no speed stopped, constant speed in the negative direction. The line right here, if you are able to find the slope of that line by taking how far it went up versus how far it went over, then you can find the speed of your object at any point in time. So if this were your graph of you walking across the street to Starbucks, we know that it took you 3 seconds to walk across the street because you're a really fast walker, and it's 5 meters. So you'd be going 5 over 3, 5 divided by 3. So that would be the slope of this line. Something else to keep in mind is that if you see a horizontal line, that means that you have no speed, that you're stopped. So your slope would actually be 0. So that's another reason why a horizontal line means no speed. It's because it's stopped. Your position is not changing relative to time. So I hope that you have enjoyed this video. Go back and watch it again. You can hear me talk to you over and over and over again. All right, have a great afternoon and the rest of your day. Bye-bye.